Today we present our project Stock Insights from Global News Sentiments, which focuses on leveraging sentiment analysis to predict stock price movements. Global events such as pandemics and election results can significantly affect stock prices. Our objective is to predict stock trends based on sentiment analysis of financial and geopolitical news. The project aims to optimize trading strategies and assist investors in making informed decisions about their uh, stocks. So in our model, we introduce some key performance indicator, which includes correlation between stock prices and market sentiments. We identify stock features for accurate stock predictions, stock price and the trend predictions, and we develop different models to predict accurately the future stock prices. Our data is gathered from multiple sources. For the stock data we mostly gather it from Yahoo Finance, and we choose the top 5 tech stocks, which has 20% of the S&P valuation. The stock news data is scraped using our own written modules from different websites. And all of these data is collected from 2011 to 2024.
Once we have the historical stock data, stock news, and global news, we use them to create features and we create targets that we want to predict. We build several machine learning models and make predictions. And to test this model on real world, we try portfolio optimization. The features that we engineered are as follows. First, we take the stock in global news and we use Vader to get sentiment scores for them. We also use our own custom lexicon. For example, if a word like war or pandemic appears, we assign a negative score to that. The stock features we use are RPM, which means it's the ratio of closing price to the simple moving average of the closing price. We use trend N, which just tells you how many days did the closing price went up in the past 10 days. And we use log returns, volatility, and volume traded. The targets we aim to predict are tomorrow's closing price, tomorrow's simple moving average, and a binary variable which tells you if the tomorrow's closing price went up compared to today's closing price. Another binary variable which tells you if tomorrow's simple moving average increased compared to today's simple moving average. And finally, we predict the percentage difference of tomorrow's closing price and today's closing price.
Depending on the stock features and target variables, we base our modeling strategy on regression models and classification models. So we use to predict stock prices, the regression models, and compare the baseline model as a time series model like ARIMA, and compare it with linear regression, k-nearest neighbor, going to gradient boosted trees and XGBoost. And for classification, whether the stock price goes up or down, we use the same models, and we see that the gradient boosted trees and XGBoost performs the best. So now when we want to compare whether the global news have any effect on the stock prices, we see there is a deep correlation between the improvement of classification matrices if we include the global news. Now, while comparing our gradient boosted trees and XGBoost with the ARIMA model, we see that ARIMA does a very poor job at predicting the stock price, whereas where the gradient boosted trees and XGBoost actually performs much better.
Then finally, we do portfolio optimization with the model metrics and predictions that we get from the machine learning models we have studied so far, which we use to calculate how many stocks we're going to leverage on a given day using this particular formula. And then we feed this formula into our trading strategy, which allows us to buy or sell stocks depending on whether the probability of the stock going up or down is related to a given threshold. And we then update the cash and positions on day D, which allows us to calculate the returns on that day using this formula. And then we complete the feedback loop. To see the portfolio growth, we start with a total investment of 100 grand. With this particular investment capital, we train our models between November 2020 and October 2023 and run the portfolio simulation between May 2024 and November 2024. And out of all the models that we have considered, gradient boosted trees turns out to give us the most portfolio growth, which is almost 3 times than a non-ML simple buy and hold strategy.
So our future directions include extending this method to other S&P 500 stocks and sectors. We would also like to look at ETF investment strategies using our portfolio optimization techniques. And we would like to develop more advanced models which uses deep neural networks to see if we can get a better predictions on the price and the trends. So with this, we would like to conclude our talk. I would like to thank DOS Institute for giving us the opportunity for doing this.